And he's calling. He said, "Oh, I have this great thing, and it's great. And could you port Mathematica? And I can't tell you what it is, but could you come out and show people on Monday?" So, I mean, you have to understand. So Mathematica has inside it probably the world's largest collection of algorithms. It supports all kinds of programming styles, data formats of all sorts. It's built with millions of lines of C code. We've got Java code. We've got the most modern C++ template stuffy widget things, and we've got ancient code that hasn't been changed since like the Reagan administration, some of which I might have written. This is not a little toy app. This is a beast. A lot to port, but not to worry, because he said, well, there's this little checkbox, and you click the little checkbox, and you'll be fine. It'll be great. So I said, oh, okay. I'll send out our crack team of emergency Macintosh developers that we keep on standby. That would be Rob. We'll see what he can do. So we put him on a plane. He gets there Thursday afternoon. Of course, I can't actually tell him why he's going, but he showed up, and they showed him the checkbox, and he clicked the little checkbox, and 2 hours later, he had a copy of Mathematica running on Intel. 2 hours. So for those of you that have been through a Carbon port, OS X kind of port, this is nothing like that. I mean, we're talking about 20 lines of source code out of millions from a dead cold start where he doesn't even know why he's showing up at Apple in 2 hours to have a working version. Let's take a look. Actually, so I mean, I should say in fairness that there is an awful lot of software engineering built into Mathematica to make this kind of thing possible. There's Rob, there's help from Apple. Your mileage may vary, but from where I stand, it's pretty good when like your biggest problem with a port is figuring out what to do with the rest of the weekend. So let's take a look here. Now, of course, the most amazing thing is just that it comes up, at launch. Now, Mathematica and the Macintosh are used by people at the forefront of their fields. People who want to push the limits and do things that haven't been done before, like that, for example. If you scroll back, those 2 lines there, you haven't seen that before. And in the spirit of pushing the limits, we thought that rather than do something boring, like port a working version that we knew was stable, we thought we'd go ahead and port the current internal development version of Mathematica, which is full of all kinds of exciting new technologies that actually I can't show you. But I can show you a couple of the interactive things we've been working on. So, oh, that's nice, now we know OpenGL works. But let me show you something that you probably haven't seen. Now, in the past, you would do typically sort of one calculation. You do one algebraic manipulation at a time, or expansion here. So what we're doing here instead is we're exploring a computational space. We have a tool where we can manipulate and navigate through a world of computation. This is a quick little example. It's simple, it's kind of fun, but it's actually based on a lot of very deep technology that we've been working on for many years to make that possible. We like to do sort of deep technology at Wolfram Research. We also like to do interesting science, hence the research. So this next example, this is something based on Stephen Wolfram's new kind of science notion of exploring a universe of possible simple programs. And as you can see, this is a very simple program. That source code up there, that's the entire source code in the Mathematica symbolic language to implement that example, as well as specify the user interface that we would like to have to explore this particular computational universe. This happens to be sort of an experimental architecture kind of idea, something you might see built in Las Vegas maybe. But it could just as well be looking at candidate nanotech structures, something like that. So we expect to be seeing a lot of sort of technological applications coming out of the use of Mathematica to explore interesting computational spaces. Okay, thanks for the demo, Rob. I'd like to So I'd like to thank Steve for inviting us out to once again sort of push the limits together with Apple. We certainly hope that we will have a universal binary shipping once there's machines out there to ship it to. And I'd particularly like to thank the Apple engineering team for freeing up my weekend. Thank you very much.
So, thank you, Teo. The key message here is to get to Xcode. Get to Xcode 2.1 and create a universal binary, and this is what's going to let us bring all of our apps over, and I think you're going to find that the tools are really, really good to do this. I think you're going to be very pleasantly surprised. But even with all of this effort, not every application is going to be universal on day one. So what are we going to do? We've got an awesome technology called Rosetta that we're going to be shipping with these new machines. And Rosetta allows us to translate PowerPC to Intel. It lets us run existing PowerPC binaries on Intel. So existing apps run. It is a dynamic binary translator. It runs existing PowerPC apps. It is transparent to users. It's nothing like Classic where you're loading a whole operating system. This is totally transparent. You just click on a PowerPC binary, it starts translating. And that's it. Users don't even know. It's lightweight, no big memory footprint, and it's pretty fast. So most users will not even know that they're running it, which is fantastic. So I'd like to just show this to you right now if I could. Let me just go over here, and I've got some apps right here. So I'm just going to open a Word document. And this is a Word document right here. And I can go up and it just thinks it's running on a PowerPC. Boom, 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 whatever it's doing. Let me open another one here. Boom. Very simple. Let me open an Excel spreadsheet. Nope. Let me open Quicken. Boom. Let me open Photoshop. Now you'll notice when Photoshop's opening, it's also loading in all the plugins. All the plugins, again, are translated. So they all work fine. There's Photoshop. Let me open another photo so you can see how fast it... Boom. And again, you can... go through stuff and do whatever you want to do. So that is Rosetta. These PowerPC apps just run. And that's what we're going to have for our users, because every app isn't going to be universal from day one. So, OS X singing on Intel processors. Xcode 2.1 to generate universal binaries.